Hey guys, welcome back. We're going to be taking a look at problem number 6 today. Problem number 6 deals with hypothesis testing. So we're going to be taking a look at a few hypothesis testing problems for 6, 7, and 8. So we'll just talk about problem 6 today. So let's go ahead and dive right in. It says a battery company is reviewing its current advertising claims. It says originally the company claimed that their batteries had a mean life of 8.2 hours. They are concerned that the quality of their batteries has gone down and the true mean is actually lower than this. So they randomly selected 54 batteries, calculated a sample mean of 7.2 hours from those 54 batteries, assuming that the population standard deviation of all batteries is 0.3 hours. You use a significance level of 0.05 to test the claim that the mean battery life is less than 8.2 hours. All right, so we want to set up a hypothesis test here. It is a hypothesis test for the mean. And notice that they give us here, and I'm going to use a highlighter here, they give us a population standard deviation. They tell us this piece of information. So we're going to be doing a z-test instead of a t-test for this one because we know the population standard deviation. That is extremely important to know what kind of a test we're going to be doing. All right, so I'm going to set up the claim, and I haven't done this before in the previous videos, but I want to talk about just identifying what the claim is and kind of write it in symbolic form. So in this case, we are testing the claim. You can kind of see here it says the claim that the mean battery life is less than 8.2 hours. So our claim is that the population mean is actually less than 8.2. So when we create our null and our alternate hypothesis, we almost always will put the claim in the alternate hypothesis. So I can always just kind of fill that in. So I'm going to say mean less than 8.2, and the null hypothesis will be that the mean is equal to 8.2, right? That's what we had assumed from our previous batteries. This is what they had been going on with their advertising and marketing claims, and now they might think that it's actually less than, so that becomes the alternate hypothesis. So we have our null, we have our alternate, and we're going to continue on here with the rest of these questions. All right, so they want to know, is this a left hand, or is this a left tail, right tail, or two tail test? So we look in the alternate hypothesis to identify that. Since it's a less than situation, we're looking at the alternate being the mean is less than 8.2. This is a left tail test. Okay, and another thing that I like to do, we identified what type of test we're doing. We know if it's a left tail or right tail. We know it's a Z test. I just like to kind of go through and write down all the important information that they gave us. And this problem, I like to pick out all of the different numbers. So for instance, our sample size was 54. So that way I just have that information nice and handy. The significance level of this test is going to be 0.05. We know the sample mean, right? So from our 54 batteries, we found a sample mean of 7.2 hours, and we had a population standard deviation of 0.3 hours. And then the last thing was our population mean, or the assumed mean, was 8.2 hours. So I just like to kind of get that out there because I'm going to be using each of those pieces of information at some point during the problem. So for instance, the population mean became the setup for my null and alternate hypothesis. All right, so to run the test, I'm going to show you how to do each of these by hand, and then at the end, I'll show you where to get this on the calculator as well. All right, so we're going to find the value of the test statistic, and remember what the test statistic tells us is how many standard deviations away from the expected value we are, right? So it's like finding a z-score, right? We want to know how far away in terms of standard deviations we are. So to calculate this, we would take our sample mean, we would subtract it from the population mean, which is what we expected to get, and then divide by the standard error. Since hypothesis tests make use of a sampling distribution, we need to make a correction for the sample size. Okay, so we're going to take the population standard deviation and divide it by the square root of n. So this is the calculation that we want to do to calculate the test statistic. And remember all those things that we kind of wrote down over here. Now it's going to come in handy. All right, so we've got 7.2 minus 8.2. That's our sample mean. This was our assumed population mean. So this is what we got from our sample. This is what we expected to get. And then our population standard deviation was 0.3, right? So I just filled in that piece. And then we're going to take the square root of our sample size down here. So this is going to be 54. So this is our calculation that we do. So if we put this into our calculator here, we should get 24.49, and that should be negative, right? So 24.49 standard deviations to the left of what we expected to get. Well, I'm thinking the battery quality has definitely gone down here because this is way below what we expected to get. So if this 8.2 were in fact true, this is where our sample ended up. And the probability of getting that far away should be pretty low. That's actually what we're going to calculate next, because that's what the p-value tells us, is what is the probability of getting 24 standard deviations away from the expected value. All right. So to calculate the p-value, we're going to use our normal distribution for this thing. So I'm going to draw a normal curve. And we're going to go back here. And somewhere over here on the left, right, we are 24.49 standard deviations away. All right, so we're trying to find the area that's in this tail to the left. That's going to get us the probability of being 24.49 standard deviations or more to the left. So we're going to set up a normal CDF here. And you'll notice that I'm using the normal function instead of the TCDF, and that's because we are running a z-test, okay? So we know the population standard deviation here, so we're not doing a TCDF, we're not finding a t-value, we're finding z-value in normal CDF because we are working with the authentic normal distribution function here. All right, so we're going to go negative 1E99, comma, negative 24.49, comma, 0, comma 1, right? That's going to be our command for the calculator. So let me pull up my calculator here and let's run that probability. So I'm going to go second distribution, and I'm going to go down to normal CDF. I got my negative 1E99 in there already. I'm going to put in negative 24.49. And then my mean and standard deviation are looking good. So I'm going to go ahead and paste that in. And notice that it said 0. And really, it's not actually 0, it's 0 plus. It's so small the calculator doesn't even recognize the plus part of it, right? That's how unlikely it is to get that from our expected value. So we would state that our p-value is equal to 0 plus. And a note on the answer key, for some reason down here on the answer key, I have this written in as negative 19.6. That should say negative 24.49. Same thing here when you do your normal CDF calculation. I don't know why I wrote down negative 19.6. I might have been looking at a different problem or something. So make sure you make that correction on your answer key. All right. And then this part right here where it says find the critical values and use it to test the claim. You don't need to do that. We didn't talk about critical value method for testing a claim. We've only talked about using the p-value, so you can scratch out part F on the study guide. All right. So the next thing that we need to do is figure out, now that we know this p-value, what is the conclusion that we should reach regarding these claims. And again, I don't know why I have insurance claims in there, right? So regarding the claim, so our p-value was 0 plus, and remember our significance level was 0.05. So the p-value is less than 0.05. All right. So at the beginning of the test, we set this as our boundary. So we said if we had a really low probability, lower than 0.05, we would reject the null hypothesis, right? So we're going to reject the idea that the mean battery life is 8.2 hours, okay? But we want to state this in English. Okay? So here's what we should say. We should say there is sufficient evidence to support the claim, right? So remember our claim was that the battery life was less than 8.2 hours, right? They had feared that the quality of their batteries had gone down. So that was the claim. And there is sufficient evidence to support the claim that the mean battery life is less than 8.2 hours. So this is what our test has told us in plain English. So we want to make sure that we say that in the context of the problem. We don't just want to simply say there's enough evidence to reject the null hypothesis. That doesn't make sense to anyone, right? Especially if they don't have statistical training like you guys do. All right, they're not going to know what you're talking about. What's a null hypothesis? What is that nonsense? Just tell me what you found out in English. So at the end of the day, we do the math. We know about the math, but there's a lot of people out there that don't, and you have to be able to translate it in a way that people understand. And you need to make sure that you are concise and that what you are saying is in fact correct. Okay, so this would be a good concise statement that tells what your data showed about these batteries. All right. All right, so now what we want to do is we want to take a look at this. How do we do this on the calculator? I showed you how to do this by hand. Let's make sure we get the same results on the calculator here. So got my calculator. We're going to turn it on. And I'm going to go to stat. I'm going to go over to test. And remember, we said we did a z-test because we knew the population standard deviation. So that's going to be the first option here in the test menu, the z-test. And we're going to make sure that we choose the stats option because we did not get the raw data from the problem. And they're going to start asking you for all the different parameters. Remember, we listed those at the beginning of the problem. So the null hypothesis or the assumed population mean was 8.2. The standard deviation was 0.3. The sample mean, what we got from our data, was 7.2. And our sample size was 54. And we are doing a left tail test. And we'll go ahead and hit calculate, and hopefully we got all the same results here, and we certainly did. So you can see our test statistic, that negative 24.49. We now, well, you've seen in the video how to calculate that by hand. We got our p-value of 0, and that's really should be a 0 plus. Like I said, this is such a small probability the calculator can't even detect the plus part. It's so far out there. So don't be fooled. It's actually not a probability of 0. Okay, and then 7.2 for our sample mean, we already knew that, and our sample size. But that p-value is really all we need to make our decision about whether or not to reject or fail to reject that null hypothesis. All right, so that's how you could do that quickly on your calculator. But do beware on the test. I probably will ask you to calculate a critical value like this, our test statistic, negative 24.49. I'll probably ask you to calculate that by hand, or I might ask you to calculate a p-value by hand. So be prepared to do some parts of the hypothesis test by hand and use your calculator as a means to verify that you did it correctly. All right, guys, that's it for today's video. Have a great day. Check back in if you need help on any of the other problems.